Good morning. I'm Dr. Navina Priyadarshini, Professor of AC Department, Rohini College of Engineering and Technology. In today's class, we shall discuss about the digital transmission system used for satellite communication. So, digital transmission, which includes the SCPC as well as multi-channel per carrier applications. So the advantages of it is high ruggedness, it provides high security, it is flexible, and is a highly economic. So when we say that is highly rugged, digital signals are less susceptible to waveform distortions such as crosstalk as well as nonlinearities and noise. Security means it has the signal is highly encrypted. So because of that, the signal cannot be decrypted by the unauthorized person. So it is highly flexible since it allows many other reconfiguring manipulations and the message transmission can be done simultaneously. And as well as economic, so to the day-to-day improvement because of the so next advantage is voice, data, and video integration. So all the types of various types of digital data signals can be integrated and can be transmitted. So compatibility with switching machines as well as power and bandwidth trade-off is possible. So the various digital transmission schemes are it supports PCM, DPCM, delta modulation, adapt delta modulation, TDM as well as FDM schemes. So in digital transmission, first we shall discuss about the PCM, that is pulse code modulation. So in pulse code modulation, it is the most widely used method. So it becomes international standard for digital voice transmission and it supports the data transmission of 64 kilobits per second. It converts the analog waveform into sequence of multi-digit or binary numbers. So this is the basic block diagram of PCM system. So first of all, it consists of the transmitter, receiver, as well as channel. So first, the signal. First of all, the signal will be an analog signal. So the signal will be generated from the source, and the signals are first of all the signal is converted into that will be a electric physical quantity that will be converted into electrical form, and it will be in the analog format and is made to transmit through a band pass filter. So this band pass filter has a particular band of frequencies, and the frequency, the signal at that is allowed to transmit, and the other signals are get eliminated. Because of that, the effects of noise added in the system is get reduced. Next, it is given to the sampler circuit. So here the sampling operation is performed. So in sampling, the samples are collected based on the Nyquist criteria. So the Nyquist criteria states that the sampling period should be at least twice the highest message bandwidth. So because by using the by based on the Nyquist criteria, the samples are collected. So at periodical intervals, the samples are collected in this continuous time signal. So at the output of the sampling circuit, it may be similar to that of the PAM waveform. Next, the sampled signal is given to the quantizer. So in usual or in general cases, we can use an 8-bit quantizer. So here this quantizer, so the 8-bit quantizer signal is quantized and the received signal is rounded to the quantization level. So it consists of n number of quantization level. So the incoming signals are generated with the bit rate of 64 kilobits per second. So at the output of the quantizer, the PCM signal is generated. And now the generated PCM signal is transmitted through the channel, and the channel consists of number of regenerated repeaters. So the main purpose of the regenerated repeater is to generate the same signal that is transmitted at the transmitting end. So by doing so, the effects of the noise which are added in the transmission path is highly reduced. And if the distance between the transmitter and receiver are far high, we will use n number of regenerated repeaters. And next, the signal is received at the receiving end. So the received signal is processed in the receiver. First of all, the received signal is decoded. So whatever the encoding schemes we have used, accordingly the signal is decoded, and the decoded signal is given to the resampler circuit. So in the resampler, we will use a clock signal for its time synchronization, and the signal from the signal, the samples are once again from the sample values, the signal is made to reconstruct. the message signal is made to reconstructed. So at the output, the reconstruction filter that reconstructs the signal and produces B in waveform, and the signal is sampled and further it is decoded. So after decoding operation, as well as the original signals are get collected. So finally, the original approximated signal is received at the receiving end. Thus the PCM signal is thus the signal is encoded and it is transmitted when it is received. Thank you.